Okay, now on to problem 3 of exam 3. We have a mass of 2 kilograms with initial velocity of 30 meters per second in the I-hat direction or the x direction, and it collides with another ball, mass 1 kilogram, which is initially sitting still. So immediately you know, because this is a collision problem that involves momentum, right? And then it says after the collision, the second mass has a velocity v2 prime of 25 meters per second. What is the velocity of the first mass, right? So here's a situation. We've got something coming in. It's going to whack into something else. After it whacks into it, right, the something else is going off at 25 meters per second, and the ball that came in and hit is heading off at some rate, but we don't know what that is, right? So this, from the problem statement, you immediately know is conservation of momentum, right? So we go down right here, conservation of momentum, right? The initial momentum P1 plus P2 equals P1 prime plus P2 prime. It equals the momentum after the collision. Momentum is conserved. So let's write this in, right? So P1. Now, these are vectors, right? But here's the thing. In this problem, they're all in the same direction, right? So they're all in the same direction. So we know because the initial velocity, the initial momentum is in the x direction with this I hat right up here. And because the momentum of the velocity, and thus the momentum of the second ball after the collision is in the I hat direction or in the x direction, like it says right here, we know that the momentum of P1 prime is also going to have to be in the x direction. Why? Because the y component of all the momentums we see is 0, right? The y component of the initial momentum of particle 2 is 0 because it's not moving at all. And so we know it's all going to be in the y direction, the x direction, and we can just write it like this, right? Plus m2 times 0, right, equals m1 v1 prime plus m2 v2 prime, right? We know, because there is nothing in y, because these are all vectors, that since there's nothing in y to begin with, there's nothing in y in the second one after the collision, there's nothing in y at all. So this is where we end up with mass 1, which is 2 kilograms, times velocity 1, which is 30 meters per second, equals mass 2, or 2 kilograms, times whatever its velocity is after the fact, right, plus mass 2, the 1 kilograms, times the 25 meters per second. And what we're after is V1, right? So we need to just solve for V1 prime, that is. V1 prime is just going to be M1 V1 minus M2 V2 prime divided by M1, right? All I did was subtracted M2 V2 prime from both sides and then divided by M1. Okay. Now it's a matter of sticking in the numbers, right? So this is going to be 2 kilograms times 30 meters per second minus 1 kilogram times 25 meters per second, all divided by M1, which is 2 kilograms. Okay, go back to Excel. 2 times 30 minus 25 over 2 equals 2 times 30 minus 25 divided by 2, and I get 17.5 meters per second. All right, there you go. That's the velocity of the first mass after the collision. And again, when you read the problem, it's talking about a collision, you immediately should jump to conservation of momentum, right? Which then looks like this, since the velocity of particle 2 is initially 0, and then you plug in your values and solve for the velocity you're after. All right, that's it for problem 3.